So, welcome to developing Nodebots using the Intel XDK IoT edition. And I've just realized I'm missing this little circle R of my Intel. So, anybody from Intel marketing here? No? Good, we're all set, fine. So my name's Stewart Christie. I'm a community manager for the developer program at Intel for the IoT pieces. And here we're here to talk about using JavaScript and a bunch of sensors to build some robots. Unfortunately, the abstract said there would be robots, and there are robots. Unfortunately, they're just not here. We've got bits and pieces of robots, but no full robots yet. But believe me, they will be coming, and they will take over the world. I say I'm part of the Intel Developer Zone. Internet of Things is up there on the left. If you've been by our booth, you can see all the other bits and pieces. We've got HTML5 and Android tools and all of those pieces. And we've recently added the Internet of Things as one of the pieces. And it's an overarching program. We've got hardware. We've got some hardware here. We're using the Galileo boards and the Edison boards. Software solutions, 4 different software solutions, C++, JavaScript, a visual programming piece. What's the 4th one? Oh, Arduino. You can program stuff in Arduino. And then online communities and training. Our road shows in the US, we had one in Mountain View a couple of weeks ago. We had one in Munich just at the past weekend, and we'll have one up in New York this coming weekend, and we're just getting ready to plan our 2015. So I'm going to start with an overview of the hardware. We've got a couple of different hardware boards that we're supporting for IoT. The Edison one is the newer one. The little Edison module is the piece on that little postage stamp size device. It plugs into an Arduino carrier there. There is a smaller version. I'm sure you'll see it later. It's a dual-core Atom. I think it's 500 megahertz. Doesn't say there. Yeah, it's a dual-core Atom. There is a Quark processor on there. So if you're familiar with Galileo, there's a Quark processor on there to power up the Atom. But it's just the core. It's not the whole Quark piece. It's just the core there. It's an Arduino board, so it's got Arduino power inputs, it's got Arduino headers for the shields. It's got Bluetooth and Wi-Fi built onto the chip. So you notice there's no Ethernet there, but we do have a couple of USB ports. One will exports Ethernet over USB as well. And there's a range of different devices you can plug into it, as I say, because it's an Arduino shield. And then the Gen 2 Galileo board. We are supporting the Gen 1, so if you've got a Gen 1 board, that's not a problem. But right now, Gen 2 are the only ones that you can buy. Again, it's compatible with the Arduino Uno. This one's got the full range of PWMs, whereas the last one didn't. It comes with, where's it here? It comes with an Ethernet port built in. It comes with a couple of USB ports, a host and device port. You can't see it on those ones. You probably can't see it up here either. But there's a PCI Express slot or mini PCI Express slot, so you can plug in a Wi-Fi card on the back. And then a couple of UARTs are in the chip, and an SD card connector that we use to boot the Linux, and that's where the Node.js resides. On the Edison, it's built into the flash. It's got a gig of flash and 4 gig of RAM on the module. Same Yocto Linux. Well, same Linux built from Yocto. Slightly different, obviously. One's for an Atom, one's for a Quark, and the Quark is more of a 486 style device with some Pentium extensions in there. Any questions about the hardware? No? Okay. So,
when you say it's compatible with Uno mechanically, is that you can slap Arduino on that connect to it?
No, you can plug on Arduino shields. Yeah. Yeah, so it's more for if you've got an Arduino shield, a motor shield, or something like that, they'll plug right on there. Yeah. If you want to connect up an Arduino, you would go through the serial ports or something like that. As part of our development kit, we're also shipping out a bunch of sensors. And you can see that at our things. We've got one here. We're working with Grove, which is a brand, well, we're working with Seed Studio, the name of the company. The Grove is their series of devices. And there's a shield that plugs into the Arduino headers, a set of cables, and then a bunch of ready-made sensors. So rather than have to plug in an LED and a resistor and a couple of jumper cables, you just connect it up. So it's very easy to get started. There's a range of sensors out there. All the pins are documented. All the schematics are up on their wiki. The layout files for the boards are up on their wiki. So if you want to modify the sensors, you can even do that. The sensors are open source. Or if you want to build your own sensors and plug them in using this sort of piece. There are 4 pins coming out. There's a ground and a 5 volt. And then 2 signal pins, input or output, or I2C, data and clock, that come up the cable as well. And you can pretty much do what you want with it. So this one here is not a Grove sensor. It's a laser from a different company, and I've just connected up basically I've just jammed the wires into the end of the connector. Because that's what makers do. One of these days I'll solder it in, but it works fine like that. So the developer program has, as I say, it's got a bunch of different software. We're going to be talking about the left-hand section. Oh well, guess our Wi-Fi is not working. So the demos are not going to be running too well if we don't get Wi-Fi. We'll cancel that. But at least we'll get back to the slides. So these are the, that was the Intel XDK, by the way, complaining about there being no connection. Pardon? Okay, well, we can try it. Yeah, we'll try that. There's supposedly a presenter Wi-Fi in the room, but they neglected to tell me the password, so if there's anybody here from the IT department knows the password for the presenter Wi-Fi, that might work. The nice thing about it, I've loaded the program onto the SD card, so it's running anyway. So we're talking about the XDK, but we've got an IoT edition. There are 2 flavors of our XDK tools. So if you go to our booth, you will see the HTML5 mobile flavor, and that's for building full JavaScript HTML5 apps and deploying on a cell phone or a tablet or into Chrome. This is the XDK edition. So what it does is it builds Node.js apps. So it's got a Node.js debugger built in. It'll deploy the Node.js files to the device through the Ethernet or the USB connection. And on the board itself, you can see we've got there on the left the Node.js support. We've got our own library that we've dropped on there, and we'll go into that later as to why we've done that. And then we've got API bindings for C, C++, the Node.js, and the Python, basically for the different languages and different IDEs that we're supporting. And then a couple of the boards at the bottom. And the sensors and actuators, we've got 12 or so in our kit. There's about 300 different sensors for these devices you can plug in, ranging from weather sensors to full health sensors that are approved for actual field trials, that can read your blood pressure or those sort of things. So there's a large range of our Arduino sensors out there that you can deploy on these things. So the developer tools, an a GUI, a WebSocket connection to the device. We've got a default port. You can see the port there. It automatically does. It'll automatically find the board. We're using Avahai on the Linux section here, and Bonjour on the PC side, or the Mac, or the Linux. And it will automatically detect the board and connect up. But there's a manual connection. You can see, I can't run the mouse from here, but there's a manual connection if you want to type in IP addresses or different things. So we've got a bunch of libraries that you can use. I mean, this is just a selection. I've deleted a couple. In fact, you can even see the dot where I deleted the couple from. So the MRA, and one of these days we'll find out what the hell it means, is the one that we're developing with our team in the UK. It's the one that sort of is built for the IoT dev kit. The IO-JS is one that's been developed by Intel Labs in China. It's very well documented because documents are generated automatically. So there's a great big website and lots of really information, and it's really difficult to understand because the documentation has been automatically created. So I'm waiting to see if they've got some examples out there we can actually use, rather than all these APIs that are well done there. So, but I would say it's more fully implemented than the MRA one at this stage. And then Johnny 5, those of you that know Nodebots know what Johnny 5 is. It's a library developed by Rick Waldron, and he's got a section of it called Galileo I/O that supports the Galileo and the Edison and those boards as well. And that Galileo I/O talks to the IMR-AA library. And if you're familiar with the Arduino and Nodebots, basically how that works is there's a piece of firmware called Firmata that's loaded onto an Arduino board, and you write your Node.js on a PC, and you send commands over through the JavaScript interpreter, sends commands to the Arduino to fire the sensors and everything. Because we are running Linux on this board, and we have our full node system on there, the Johnny 5 can detect that and automatically just runs right on the board. So there's no need for a PC. So it runs standalone. And then the I2C library there, we're running Linux, as I say. So the file system, the sysfs file system, is how we access the GPIOs. And you can see that in the example. This is how it's deployed. We have two WebSocket channels, one for the debugger. All right, so the Node.js app is main.js or whatever. And on the left, you can see the debug channel. So it uses the V8 debug protocol on the IoT device. And then we use the Chrome debug protocol. So it's the Chrome debugger that shows up when you hit the debug button. And on the right-hand side, we have a separate WebSocket section there that does the start, stop, run, download pieces there. So it's quite nice. You can run the debugger, and then you can hit the start and stop button, right, and they'll work independently. The daemon that runs on Node.js and does the connection between XDK and the system is itself a Node.js program. So we've got JavaScript programming that allows you to download and drop all these programs on there. If you want a command line, that's fine, right? It drops these programs into a directory, Node app slot directory on the system. You can go in there and edit the file with VI. You can run it, you can kill it, you can run multiple copies of it if you want to as well. So it's easy to use, right? It's got the run, start, stop buttons, but we haven't broken anything in the regular Node.js. So you can download packages using NPM onto your system, or you can do it through XDK. Either way works. We've even found out recently, or one of our developers did, this is our graphical tool. It's developed by a company called Willy Odrin. And as you see there, it's their visual Python programming at the bottom there for Arduino. And it's based on like Scratch or Google Blocks. So you can see there on the right-hand side, nice little program there that gets the temperature in degrees. Yeah, and creates a little weather station. There's a JavaScript button in the GUI. And if you click the JavaScript button, it creates the JavaScript, and you cut and paste it into XDK, and you've got a graphical JavaScript creation program as well now. It'll still do the Python. The Python piece deploys automatically. The JavaScript is a bit more cut and paste, but it works great. And so we've had some people use this, at least to get the first framework up and running. Right, gives them a nice easy flow, and then they can edit it in the text editor. It's only available right now for the Galileo. We're working on getting the connection piece to the Edison working as well. But that's another alternative if you're a JavaScript challenge developer and you want something graphical to get started with, or you've got children. It's really nice. It'll run on a tablet and deploy over Wi-Fi to the boards. So a little bit about the library. Before we start, on the bottom right-hand side, you can see the breakout board. This is the new board that we're supporting now. So the Edison, we've got our large Arduino board, right? This is the smaller breakout board for the Edison. So you can see the size. There's a couple of USB connectors on the right-hand side, and basically those are 0.1 pin headers. So it's probably about the size of this battery. Right. So you plug on the Edison module onto there. You've got a full PC running on a thing like that. You can plug it on to a 9-volt battery because it takes a 7 to 15 volt input as well. So you can just plug that right in there and get yourself a working system like that. And the library that we've developed comes in two flavors. The MRAA is the low-level one, and it has the sort of features on the left there. It auto-detects, as I say, which board it's running on, which is why it now supports the Edison breakout board. When we brought it out to start with, we didn't support the board, and people were sending us messages about their Edison board not working. We'd no idea what they're talking about. But there on the left, you can see the sort of pieces it can do, right? Is it a valid pin, right? There are 8 digital pins. If you tell it to connect to digital pin 10, it's not going to do it. It's going to send an error message. So it does some validation of the boards, and it can detect the different features on the different boards. So you can write one program and deploy it, but if it's not supported by the different variations of boards, it will detect that. The GPIO is basically what it sounds like, right? Digital in, digital out. A lot of the digital in and digital out is used to select multiplexers and do different pieces, but no, if you just want to use a pin, the Arduino pin, you can just use those ones. PWM, it supports the faster GPIO. There is some high-speed GPIO on these devices directly out of the chip. Most of the Arduino I/O is run through an I2C adapter to create an Arduino compatible connection. So the PWMs can be switched on, or the GPIO can be switched on. So it's emulating an Arduino, but some of these faster GPIO pins are natively right out of the Galileo or the Quark chip, and they're done that way. The SPI bus and the I2C are just native, regular on the board inside the chip devices. And then the analog in is a separate A to D converter. So there's an A to D converter on the board to simulate the A to D within the Atmel chips on the Arduino. Their Arduinos are 10 bits. This is a 12-bit A to D. You'll get, if you read it raw, you get 12-bit numbers. If you read it through the Arduino version of the library, you get a 10-bit version. But you've got some more accuracy there. On the right is the high-level sensors. The high-level implementation of a button is not really something I would recommend you use because it's a GPIO button. It's right one pin. But some of the more complicated sensors, the temperature sensors or the light sensors, they'll actually return a value in degrees as opposed to no, a number between 0 and 1024. The libraries are, as I say, are added continually. We get more sensors, we buy more devices, we add some more support. So this one is just a simple, well, very simple GPIO one. Again, it's just requiring the GPIO pin 8 is the pin 8 on the board. You set the direction and you write to it with a value of 1 on this piece here. There is support in the libmraa for all of the GPIOs on the board. So you can write a program and write to GPIO 37, which is the GPIO that on the board that will enable a chip select. And basically, we've blown up a few boards when we did our debugging at the beginning. So we would recommend you use the Arduino pin numbers. The stuff's been debugged, but it is a low-level library, so you can access any of the system FS files. If you can read a schematic, you'll be okay. All right, that's the piece, the way you've got to work it. So some of the example projects we've got built into our XDK. I'll switch this on while we're waiting and see if we can get the network going. So we've got a series of programs that are bolted into our development system. There we go. Starting to boot Linux. Coffee cup out the way. So a selection of fairly simple programs built into it at this stage. We launched it 30th of September or 1st of October. So it's got a fair ways to go. As you can imagine, something that's we've had one fixed release. The XDK team generally launch new versions every 6 weeks or so. So there's a new refresh every 6 weeks for this XDK and for the HTML5 piece. So we're hoping to get some more samples. There are some more samples out there on YouTube and on GitHub, but not bolted into this yet. So local temperature. The local temperature one is interesting. It will read the temperature sensor and then connect via WebSockets to an HTML5 app on a phone, and it will draw the graph of the temperature sensor there. Analog, digital read, digital write are pretty basic GPIO capabilities. The onboard LED blink is the standard Arduino get your board up and running piece. And then we have a PWM one, which I decided to use a real LED or a laser LED rather than a little LED. I'm not sure if the PWM is going to work or if you're going to be able to see it from there. But it's running on a loop. Is it going to get dim? I don't think so. I think it's just so damn bright. There's bright and really bright. You can't do much with a laser. It is running a PWM, but right, it's going off and on, but it's going off and on so damn fast you can't tell. See if it works with my hand. No better. It's fairly bright right now, as you can see. And when it goes dull, you probably won't notice it because your eyes are on things that are working as right as be. Trust me. It's working. With a real LED, it's even worse. So at least you can see there's a light on it. So we've got PWM working, and then the touch notifier is again a program that connects to a separate app on a phone. So there's a touch sensor that's in our kit, and you can connect up to that. So one of the things you may find you're doing when you're deploying out a real program, as opposed to just a little rinky-dink one, is you have to install some packages. And this one is, you can't quite see it up the top there, but it's Socket.io, right? And if anybody's ever tried to install Socket.io on a Windows PC and managed, please let me know how you did it. You have to install Visual Studio, you have to get all the paths right and everything. I've done it on Linux, it works great. But you have to, it's got some C code in there that connects to the hardware and has to be compiled on your target. So we've got a GCC compiler on the board, on the SD card. And we can download the packages, so we're seeing them there at the top. Uploading the project bundle to the IoT device, and then we send it the clean message, and it rebuilds all of the packages. So you can select, you just put in your JSON file, the dependencies, and then you say, okay, build everything. It will go and get those packages, and it will send them over the Ethernet or whatever connection you've got to your board and install them. And if they need to be built with GCC, it will do that as well. So you can do it all through the GUI, right? As I say, because we've got GCC and all the build tools there on the board. It's a very optimistic message, may take several minutes, right? It takes about 15 minutes to download a big set of files and build it and do that. It's not really meant as a development system, but no, it will get through it, right? It's a 400 megahertz device, and the SSD card is the SD card. So it's not a fast disk either, but it will build it. No, you get at the bottom, you get your NPM rebuild complete. So you can deploy it like that, or just say you can download the packages yourself through the console on the Linux box, and go from there. This is basically all we've got. If I can get the Ethernet working, and we'll be able to maybe run some demos and show you stuff. I would recommend that you download some of the software, get yourself a sensor kit, and try it out. Now, if you want to try it out, we have 20 systems. I've got 10 built. I've got the rest of the afternoon to build the other 10. And we'll be in the F50 room just across the hall there, and we'll have 20 of these systems set up with XDK and with the Arduino code, with a light sensor that can detect the meniscus in a glass of beer. So you can set it up, you put in a small glass of beer, when it gets to about 1/4 inch, you get a danger low beer alert, and then the waitress can bring you a new beer. So we've got that up and running. We've got about 10 of them built to say I'm going to sit in the Intel booth and build the rest this afternoon. And if you want to come along, bring a beer. We've got tickets in the Intel booth for free beer as well, which helps. And try this out, right? if you build a better beer detector, we have 3 systems that we're giving away. So the board and the sensor kit. The rules are I'm making them up after I've had a few beers. But generally, it's you have to make a better beer detector than our crappy one. You have to have a really cool name for your beer detector, right? The what was it? The highly technical. What was it? I've forgotten what it is. Somebody came up with a nice one that said HTML, right? That one's already taken. But you have to have a nice name for your project, or you can just buy me a free beer. That works as well. So if you want to try that, we'll say we're in the social event tonight with 20 of these systems. We're running them with Arduino. We'll have the XDK tools installed as well. So if somebody's got some JavaScript pieces, you can try that. Now I'm going to see if I can connect this system up and see if we can get the Wi-Fi working and get the demo running as well. So bear with me. Let's just try the Wi-Fi, see how that goes. I just need to pretend to log in. So I say there's the sample apps that we were showing earlier. We'll load in simple analog read one. You can get the source, the latest source from GitHub, or you can just use the template that's installed with this. Depends how up to date you want to be. There you go, the demo gods. Yeah. So let's restart XDK and see what happens. We'll plug in my laser and see what happens, if we can get that going. So any questions while we're restarting? Sure.
Yeah, I have a question. I'm not much of a hardware guy, and I'm just starting to understand the differences between, say, using Arduino and Raspberry Pi. Where does this Galileo and Edison fit in with Raspberry Pi?
It's, I would call it like a super Arduino. So it fits in between the regular Arduinos and the Raspberry Pi or the BeagleBone pieces. The Raspberry Pis and the BeagleBones have got HDMI output and some of the graphical engines built into their chips. The regular Arduinos are 8-bit Atmel microprocessors. So we can run the same software as the Arduino. We can run the sketches and everything. We've got an Arduino IDE. But we've got Linux running as well. So you can run a sketch from the Arduino. You can run a Node.js app. You can run a C++ app. And you can run a Willy Odrin Python piece simultaneously. Pricing-wise, an Arduino is about 20 bucks. The time you bolt on the Ethernet shield and then the power supply, you're about the same price as the Galileo. We ship the power supply and the board with the Ethernet for about 65 bucks from Amazon. So it's about the same. You just get the extra features. So it's more, what do you want to build, right? Do you want something with Ethernet or Wi-Fi? Then fine, right? If you're just building a blinky light thing to do your Christmas lights, stick with an Arduino, right? That's all you need to do. We use Arduino based motor shields to plug into the Galileo to drive the motors. I pressed the wrong button. Let's see what happens. Okay. What time we're supposed to finish here? 12:30, so we've got 10 minutes. Yeah. Well, I'm going to give up because it's crashed twice, and that's an omen as far as I'm concerned. We do have it running in the booth if you'd like to go by and have a look at it there. I'm going to write some nasty messages to the developers on this, so I'll switch the display off. But if anybody's got any questions or you want to come up, we've got the sensor kit up here, as well as the boards, and you're welcome to have a look at those. Thanks very much.
Thank you.